This is 2.1 linear equations in two variables. Some of this will seem quite familiar with you. Way back in Algebra 1, you covered a lot of this material. So let's begin with slope-intercept form. This is probably the most common form, y equals mx plus b. This is a lot of times what you know, if you're using a graphing calculator, this is what you would commonly substitute into your equation. The m is your slope, the slope of the line. The b is the y-intercept, where it crosses the y line at. So two examples. So here it says y equals, again, notice it's in y equals mx plus b. So the b, the y-intercept, is -4. So you can see the y-intercept is -4. So you're going to start on the y line at -4. And then from there, it's rise over run. Slope is defined as rise over run. And so you're going to rise 2 and then run 3. And again, I always encourage students to run to the right. So up 2, run 3. Up 2, run 3. So notice I'm going up 2, over 3 to the right, up 2, over 3 to the right, up 2, over 3 to the right. The more points you put, the more accurate your line will be. So 3 points is better than 2. 4 points is better than 3. So the more points you put, it's going to be more accurate. Now notice also, instead of going up 2 and 3 to the right, I could actually go down 2 and 3 to the left. I always encourage, again, going to the right is better, just stay consistent. But in some cases, depending on the equation, you could go down and to the left instead of up and to the right. But notice also when you connect it, again, the more points you put, the better. Also notice, if you were going uphill, notice you draw your little man on the left hand of the line. Notice that he's going uphill. It's a positive slope. So a lot of times students will do the slope wrong, and they don't even notice that their slope is going in the wrong direction. So always notice that at the last minute. All right, so sketch the next example, y equals -2x plus 4. Again, so this is your y-intercept at +4. And then from there, the slope is rise over 1, so down 2. And I always run to the right. That's what I encourage students to do. So down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right. And the more points you put, the more accurate your line will be. I encourage you to put as many points as possible so that your lines will be very, very great. All right, that's y equals mx plus b. Also, just as a reminder, we just got done talking about slope as rise over run, but the actual formula between 2 points is y2 minus y1 divided by x2 minus x1. So here you have xy, here you have xy. So if I wanted to calculate the slope, I'm just going to follow the formula y2 minus y1 divided by x2 minus x1. So that's -5 on the top, and then that's -4 on the bottom, so that's 5/4. So, and to double check, I encourage you especially to double check it. If you take a piece of graph paper out, -2, 4 is right there, and then go to -6, 1 is right there. So if this was the line, and we wanted to find the slope, notice he's going uphill, so I should have a positive answer to be able to do this. Notice it's going up 5 over 4, and it's a good thing I'm double checking. So normally I would start a video all over and do this, but this is a good point because I made a simple math mistake, and it's a good thing I'm double checking. So 1 minus 4 is not -5. That's a good thing I'm double checking here. So 1 minus 4 is -3, and that would give us +3/4. So one tiny simple mistake, I caught it because I drew a piece of paper, graph paper, and notice I'm going up 3, and then I'm going over 4. So even the simplest mistakes that we do sometimes can be caught if we double check it, and we can see it on a piece of graph paper as well. All right, so point slope form. Notice point slope form, I think, is a very good form because one, notice on this I have a point, I have slope, so why not use point slope form? So if you follow the formula, so y minus y1, which is going to be plus, and then m is 1/2 x minus x1. So notice what you're doing is you're substituting in there, there, and there. You're substituting those in. I also want you to pay attention as well. Notice I had a positive 4, but it looks like a negative 4 in the formula, and then I have a negative 1, but it looks like a positive 1 in the formula. So whenever you're using point slope, because of the formula saying subtraction, it's actually going to change the signs. Which is pretty nice. So, and I also wanted to point out to you, there's a way to double check this. One, how do you graph this? Well, one, you have a point, so go to the point 4, -1. And then the slope is 1/2, so go up 1 over 2, up 1 over 2, up 1 over 2. And then you have a line. The other thing you can do is if you use the distributive property, notice what I have is y equals mx plus b, and notice I can the y-intercept is -3. Now my graph's a little off just because I kind of connected it really quick. But if you kept doing the slope, up 1 over 2, up 1 over 2, or you can go down 1 and then 2 to the left, down 1 and 2 to the left, down 1 and 2 to the left. Notice that this line actually does cross at -3. See, that's what you see. It crosses. This is your y-intercept. So you can always check it. Once you put it in slope, a point slope form, you can always check it by just simply using the distributive property and solving for y. All right, so parallel and perpendicular lines. So parallel lines have the same slope, and perpendicular lines have opposite reciprocal slope. So here's 3 lines. Notice the blue and the red, they have the same slope. They're both going up 2 over 3, up 2 over 3. And then notice the green, it has to have 2 things. For perpendicular lines, perpendicular means it hits at 90 degrees, like it literally hits at 90. A lot of times with 90 degrees we see a box right here, and that means it's a right angle. That's what perpendicular means. So the green line intersects the blue and the red line at 90 degrees. So they also have opposite and reciprocal. Opposite and reciprocal. So notice the blue and the red have 2 over 3, but the green is 3 over 2, and it's negative. So these were positive, so this is going to be negative. These were 2 over 3, then this one's going to be 3 over 2. And then that's how you tell the difference if it's parallel or perpendicular lines. All right, so if we walk our way all the way through this, so here we have an example of 2 points, and we're going to find the slope. So y2 minus y1 over x2 minus x1. So 2 over -2 or -1 slope. So write the equation of the line. Well, I suggest you use point slope form. So y minus y1 equals m parentheses x minus x1. And just choose one of those points. It does not make a difference. I'm just going to choose 1, 3. So y minus 3 equals -1, x minus 1. That is the equation of the line that goes through both points. It goes through both points. And all we're going to do is now go on to the next equation. It says write an equation of a line that is parallel. Well, what do you know about parallel lines? Well, parallel lines have the same slope. Well, this has a slope of -1, so we're going to use the same slope as -1. So, but we're going to use this point. So y minus -6 or plus 6, and we're going to use the same slope, and then x minus 3. And then notice the last equation, write an equation of a line that is perpendicular. Well, perpendicular means has opposite and reciprocal. So the slope for this line is +1, because if we do the opposite of -1 and the reciprocal of -1, it's going to be +1. So we're going to use y minus 4, because we're using this point, then +1, then x plus 1. So notice I wrote the equation. If we graph all of these now, you'll see that these two lines are parallel. This line and this line are parallel, and then this line right here is perpendicular. And this was my original 2 points. Goes through this thing right here, that equation. So you can literally graph this to double check it. All right, so let's look at a word problem. So an exercise equipment costs $12,000 and has an expectancy life of 8 years. The salvage value at the end of the 8 years is $2,000. So writing a linear equation that describes the value of the equipment. Well, notice, like if we did like a sort of like an XY chart. So it's really what we're going to do is time and value. So notice at the very beginning, so time 0, the value was $12,000. And notice at the end of 8 years, the value was $2,000. So notice these are literally 2 points. It's 2 points. So if we literally found the slope of this, so literally y2 minus y1, so 2,000 minus 12,000 over x2 minus x1, so 8 minus 0. So we're going to get negative 10,000 over 8, which is negative 1250. So notice the slope of this line is negative 1,250, which again, that's basically how much it's decreasing every single year. That's really what's happening. It's decreasing every single year at an average of $1,250. So if you think about this, like now you can actually write the equation. If you use point slope, let's use point slope. So y minus, and I don't care which point. Let's use this point right here. So y minus 2,000 equals negative 1250 x minus 8. So if that's the equation we want to use, or again, if we wanted to use this one, so again, you can use point slope if you wanted to for this one. So y minus 12,000 50 and x minus 0, or just x, because x minus 0. So if we just wrote x there. And so this one's actually pretty easy, because now we can do now we have y equals mx plus b. Very easy. We could have done y equals mx plus b on this one as well. It would have been a little bit more work to do. So notice that's y equals mx plus b. And we can literally just plug that into our graphing calculator, and if we wanted to, and then fill out, like, after 1 year, we could see the value of the exercise equipment. It's $10,750. After 2 years, it's $9,500. And then, so forth. So we could literally find, like, 7 years that the equipment is $3,250. So, and we can keep predicting that over and over. So look at one more problem. So Best Buy sold $35.9 million in 2006 and then $40 billion in 2007. Write an equation of sales in billions of dollars to predict the sales for each of these years. So very similar to the last problem. So we made an XY chart, starting values, we found the slope, we wrote the equation of it, and then I put it in y equals mx plus b. And if you simply just take this y equals mx plus b, then you can see that, you can literally look at year 10, 2010 is 52.3, and year 2015 would be 72.8. 2025. And we're just making predictions. Obviously, Best Buy may not be doing this. $113.8 billion. These are just predictions based on the model of growth.